today is the last topic in our communication system subject. So up to now we have seen what is meant by communication and analog communication and digital communication. In analog communication we have seen about amplitude modulation, frequency modulation and phase modulation. So how these modulation techniques are going to be used in applications and how we are going to generate a AM waveform or FM waveform or PM waveform and how we are going to detect at the receiver side all these three waveforms corresponding or respectively. After that we have seen about some small part in receivers, and then we have seen about the digital communications. In the digital communication systems especially we have seen about the pulse code modulation. After that the differences between ASK, FSK, PSK with respect to probability of error, and some basics of about information theory and channel capacity theorem, and how that in the information theory how that source coding is going to be happen, different types of source codings, that and all we have seen from the past few classes. And now today we are going to see about the noise, and this is the last topic. And okay, so this is a noise. So generally we have noise. We have transmitter this side, and here receiver is there. Okay, so in between this is a channel. Okay, so here only this noise will come. Noise will affect more on the channel during the transmission. This will affect more on signal while transmitting. Okay, and how these noises we are going to define, and these noises, what are the types of these noises, internal and external noises, how this will be varying for different types of techniques. Suppose let us take an example, AM, FM and DSB, SC, SSB receiver, how all these receivers, how this noise is going to be affecting, and these are the things we are going to see now. Okay, in this mainly noise is nothing but any unwanted signal. Okay, noise is any unwanted signal. Any unwanted signal is nothing but a noise. Okay, so this noise we can define in two ways. Okay, the one is external noise and internal noise. We can say external noise, and next is internal noise. So here external noise means I can divide this into one is atmospheric noise, solar noise, so something like that. Atmospheric noise, solar noise, and industrial noise. You know why this will come? Due to the atmospheric changes like thunderstorms, all those things, you will get this atmospheric noise. And next is the solar noise. This solar noise you will get due to the sun, galaxy, stars, all those things like that. And industrial noise. So this industrial noise will come due to the industries. Most of the pollutions are sound pollution or water pollution, air pollution, all those things. Okay, and now this is an internal noise. Okay, so here internal noise I can go for thermal noise or white noise. Okay, so this thermal noise, so how it is going to be used? The thermal noise power, this is the only thing we are going to see in the internal noises, the thermal noise or white noise. Okay, so this thermal noise power, thermal noise power is equal to kTb watts. Okay, kTb watts. So here if you can see kTb watts. Okay, this is the thermal noise power. So by this equation, this thermal noise is independent of frequency. That is the most important thing. Independent of F. This thermal noise is independent of F. Here, if you can see, this K is Boltzmann constant. K is equal to Boltzmann constant, and T in degree Celsius, T in degree Kelvin, B equal to bandwidth. So this is K is Boltzmann constant, T in degree Kelvin, temperature in degree Kelvin, beta is, B is bandwidth. So here this thermal noise power is independent of frequency. That is the thing we have to see. And K T is power spectral density. Power spectral density. Okay. So now here this thermal noise or white noise. This white noise, if it is a single sided or a double sided. So if it is single sided, then this is the graphical representation, KT by N0 by N0. This is N0. Okay, this is a single side thermal noise. If you take the same thing as a double side, then you will get it N0 by 2. Single side, double side. Okay, so this is a single side spreaded KT, double side spreaded KT. This is KT is power spectral density. KT is power spectral density. That is going to be spread in both sides. Then we can call it as a double side. Okay. Or if it is a single side, then we can call it as a single sided white noise or thermal noise. Okay. So this power spectral density, we can see that as a watts per hertz. Units are watts per hertz, beta. So the units for thermal noise is KTB. This KT is watts per hertz, and bandwidth is in hertz. Hertz gets cancelled. You will get watts is the unit for this thermal noise power. And these are the things, basic things about that one. This is a spreaded in time or frequency scale. Okay, single sided and double sided. Now if you'll see